Why do astronomers imagine that dark energy exists? It has never been observed in any way at all, but without this invisible energy, the Big Bang Theory is simply impossible. Now, let's investigate the facts. Many massive galaxies, some with as many as 200 billion suns, are traveling at near light speeds. Accelerating a massive galaxy to near light speeds requires an incredibly huge amount of energy. The kinetic energy of motion of these galaxies is over 100 times more energy than we observe in the entire universe. In order to make their Big Bang Theory possible, astronomers claim that we can only observe less than 1% of the universe's energy and that the rest is invisible, dark energy. My white hole theory proposes a more realistic possibility. Before making their surrounding galaxies, white holes were roughly the mass and shape of a piece of paper, probably longer and wider, but only one atom thick. The mass of these super skinny white holes was almost zero. Therefore, the energy to accelerate a very thin white hole to near light speeds is less than a light bulb. Now, as we look at the math, consider which is more likely to exist at the dawn of the universe. 100 times more energy than all of the universe's energy combined, or the energy of a few light bulbs. Now let's turn to our whiteboard, and we will see why do astronomers need dark energy. Let's look at the formula first of all. Kinetic energy, the formula for kinetic energy is 1/2 mass times velocity squared. On the left side, we have the Big Bang Theory. On the right side, we have my white hole theory. So, looking at the kinetic energy for the Big Bang Theory, we have 1/2 of a solar mass, which is the mass of a sun, times 100 billion suns, which is an average large galaxy, times the speed of light squared. Now, I guess we'll work through that equation first. So we look at that. 1/2 of the solar mass is 10 to the 30th kilograms. That's 10 with 30 zeros, times 100 billion suns, which is 10 to the 11th, times the speed of light, almost three times, 10 to the 8th meters per second squared. That ends up being 10 to the 58th power, or 10 with 58 zeros behind it, kilogram meters squared per second. That's about roughly similar to the total energy of our entire universe. Very unrealistic. Didn't happen. On the other hand, let's look at my white hole theory, the energy requirements for this theory to be true. We have 1/2 the mass of a white hole, which I'm estimating to be about 20 million atoms, or 20 million neutrons, times the speed of light squared. Now, 20 million is 10 to the 7th. The mass of an atom is 10 to the minus 24th. That's 1/10 with 24 zeros, kilograms, times 3 times 10 to the 8th meters per second squared. Okay, so when we boil down that math, it ends up the mass of the white hole is 10 to the minus 17th kilograms times 10 to the 17th meters squared per second. So it ends up basically being about 1 kilogram meter squared per second, which is about 1 joule, which is, well, quite frankly, less than 1 light bulb. So which is more likely to exist? Do we need dark energy? No, we don't. What we really need is just a realistic theory and plausible theory about the creation of the universe, which is my white hole theory. Thank you.